All right, today we're talking about the tiny, secret hero that built our entire digital world. I'm talking about the transistor. It's probably the most important invention you've never actually laid eyes on. So let's get into it.
So let me ask you this. What do you think is the most important invention you've never actually seen? And no, I'm not talking about the wheel or the printing press. It's something way, way smaller. In fact, there are literally billions of them inside the very device you're watching this on right now.
You know, to really get why this was such a big deal, you got to look at what it replaced. Before the transistor, we had these things called vacuum tubes, and they were just awful. They were huge, they got super hot, and they were famous for breaking down. But then, along comes this new champion, the transistor. It was tiny, it ran cool, and it was unbelievably efficient. It wasn't just a better version, it was a complete game changer.
And that one tiny change, that's what led to the literal revolution you're carrying around in your pocket right now. This is the story of the unsung hero of all modern electronics.
Okay, so what is this thing really? Well, at its core, a transistor is basically a tiny little device made from something called a semiconductor. Its job is to control electricity. It can adjust the flow, it can boost signals, but its most important job, the one that changed everything, is acting like an incredibly fast electronic switch.
And that one simple idea, a switch, that's the secret sauce. That's where all the magic happens. So let's pull back the curtain a little and see how this one function builds, well, everything.
So a transistor really has two big jobs. First, it's a switch, and it's a crazy fast one. It can flip a signal on or off billions of times a second. That's how you get the ones and zeros, the basic language of every computer. But second, it's also an amplifier. It can take a tiny little bit of electricity and turn it into a much bigger signal. It's kind of like turning up the volume on a weak radio signal so you can actually hear the music.
So how does that switch actually work? Well, just think of it like a gatekeeper for electricity. It's got three parts. You've got the emitter, which is where the power comes from. Then you've got the collector, which is where the power wants to go. And right in the middle, you have the base. That's the gatekeeper. Or maybe think of it as the on button. When you send a tiny little jolt of electricity to the base, the gate swings open, and a much bigger flow of power can rush from the emitter to the collector. No jolt to the base, the gate stays shut. That's it. It's really that simple.
And the secret ingredient that makes this whole gatekeeper thing possible? It's a special material called a semiconductor. The most famous one, of course, is silicon. See, it's not a full-on conductor like copper, but it's not an insulator like rubber either. It's something in between, and that's its superpower. Its ability to conduct electricity can be flicked on and off with incredible precision. And that's the magic that lets you build a perfect little electronic switch. So, once we had this tiny, perfectly controllable switch, humanity suddenly had the one tool it needed to build the entire modern world. Let's take a look at how the transistor went from just a cool idea in a lab to becoming the literal Lego brick of our digital age. And the timeline for this thing taking over, it's just mind-blowing. It was invented back in 1947 at Bell Labs, and right away, it kicked off this massive shrinking revolution. But the real explosion, the moment things went into overdrive, was in 1965. And it was all because of a simple observation that basically became the North Star for the entire tech industry.
Yeah, Gordon Moore, one of the founders of Intel, he noticed something. He predicted that the number of transistors we could cram onto a single chip would pretty much double every 2 years. Now, this wasn't some law of physics. It was more like a challenge, a dare. It became this incredible self-fulfilling prophecy that just pushed engineers to go smaller, faster, and more powerful year after year after year.
And to give you some perspective here, back then, one of the very first integrated circuits, or ICs, held about 1,000 transistors. Just 1,000. And at the time, people's minds were blown. 1,000 tiny switches on one little sliver of silicon, that was an absolute marvel of engineering.
Okay, so fast forward to today. A modern microprocessor doesn't have 1,000. It doesn't have 1,000,000. It has billions. We're talking billions with a B. Billions of those tiny switches all crammed onto a chip that's about the size of your fingernail. I mean, the leap forward is just
It's almost impossible to wrap your head around.
And every single one of those billions of switches is working in perfect harmony, flipping on and off at incredible speeds. They're forming the logic gates that run your apps, the memory cells that save your photos, everything that connects you to the internet. They really are the fundamental building blocks, like the atoms, of our entire digital universe.
So you might be thinking, if we're already at billions, where could we possibly go from here? Is there even anywhere left to go? Well, the quest for smaller, faster, and smarter, it's far from over.
Believe it or not, the future is somehow even smaller. Engineers are now working on these wild new 3D designs with names like fork sheets and nanosheets just to find new ways to pack more in. And you might ask, why go to all that trouble? Well, it's simple. Smaller transistors switch faster, which means more performance for you. And they use less power, which means better battery life. And even with exciting new stuff on the horizon like quantum computing, you can bet our good old trusty transistors are going to remain the bedrock of our everyday tech for a long, long time.
So there you have it, the transistor, the invisible hero that took us from computers the size of a room to literally putting a universe of information right in our pockets. It's the ultimate proof that sometimes the biggest revolutions come from the smallest things imaginable. And it really makes you wonder, doesn't it? What's the next microscopic hero going to be? And what incredible things will it make possible?